Okay, let's go ahead and get started. This is Chapter 5 and 6 exam review. You should have the exam review sheet in front of you. If not, just go ahead and download that, and you'll have that available to you. All right, the first question is to distinguish between the periodic tables proposed by Mendeleev and Moseley. Let me go ahead and turn the light off here so we can get a little bit better view. So, first of all, any discussion of the periodic table without mentioning Dmitry Mendeleev, of course, is going to be incomplete. 1869, Russian scientist, we said Mendeleev was instrumental in the development of the periodic table. Remember that he arranged the elements in order of increasing atomic mass, so make sure that you remember that to associate Mendeleev with atomic mass and not atomic number. What is meant? Excuse me, let's get back to Mendeleev and Moseley. So Mendeleev, remember, there were difficulties with the Mendeleev table. One of them was that when Mendeleev put the elements together, that there were, in order of increasing atomic mass, that there were empty spaces. And that those empty spaces represented elements that had not yet been discovered. So keep that in mind. Empty spaces were elements that were not yet discovered. Nonetheless, when Mendeleev put the elements in order of increasing atomic mass, elements with similar physical characteristics were kind of grouped together. So that's the idea of periodicity, that when he ordered them in order of increasing atomic mass, that once again and again, the elements with similar physical characteristics were grouped together. So that's the idea of periodicity. Okay, other discrepancies. First of all, when Mendeleev did that, there were elements that should have been in certain categories and certain spaces, and they just weren't there. Other times, elements that should have been in some other category were put into the wrong category, and so Mendeleev simply took those out. And so that was another discrepancy. Another one was that Mendeleev had no knowledge of valence electrons or orbitals or anything like that, so he had no real explanation for why the periodicity phenomenon was occurring. So that's really all there was for Mendeleev. Moseley in 1913 was a British scientist. He came along and said, look, let's put these elements in order of increasing atomic number. And when he did that, that resolved many of the problems of the Moseley model. And that's really all we need to know with regard to Moseley and Mendeleev and their versions of the periodic table. The second question has to do with periodicity and the modern periodic law. It says what is meant by periodicity in the modern periodic law. We've already discussed periodicity. It means this idea of recurring phenomena, that when you look at the periodic table, you see that elements have similar physical and chemical characteristics that recur over and over and over again. The modern periodic law, we discussed that when elements are arranged in order of increasing atomic number, elements with similar properties appear at regular intervals. So keep that in mind. Number 3, you should know the position of the following on the periodic table: the alkali metals, the alkaline earth metals, the transition metals, the metalloids, nonmetals, halogens, noble gases, intertransition metals, the lanthanide and the actinide series. So let's take a look at those. First of all, remember that the metals are everything on the left side of the periodic table. All these over here are the metals. Everything that you see here in yellow is metals. We'll go over it on the real periodic table again in just a minute. So all of these are metals. The notable exception is hydrogen. It's on this side of the periodic table, but that lime green color indicates that it should be over here with the nonmetals. The nonmetals are the lime green. They're these ones over here on this side of the periodic table. To the right of this stair step right here, and this stair step is very important because what this designates is the division between metals over here and nonmetals on this side. The metalloids are shown in purple here. These 6, 1, 2, 3, 4, 5, 6. Everything that's touching the stair step, but not including aluminum and polonium. These two, aluminum and polonium, should not be included. So that's that. You, on number 4, are required to know the various levels of the positions of the sublevels, and on the periodic table it's very easy to find. S block is right here. These are the main group elements, by the way, which you see in purple here and here. The main group elements here and here. This is the S block right here. This is the S block here. The P block over here. The D block is here, and the F block is here. F block is down here in lime green. Okay, transition metals are the yellow. Intertransition metals are those that are down here. Remember, that's the lanthanide and actinide series That's the F block. Let me go back to the periodic table. I'll turn the lights on here. Let's come on back this way, the periodic table. So once again, the alkali metals are this group right here. This is the alkali metal group right here. The first group right there, they're extremely reactive with water. The alkaline earth metals are the second block right here, alkaline earth metals. Transition metals are this block right here. It's also known as the D block metals right here. The last column right here, extremely unreactive with really anything. These are the noble gases, neon, argon, krypton, and so forth are the noble gases. They have a filled octet of electrons. Fluorine, chlorine, bromine, and so forth. These are the halogens here. These elements here are generally named by the highest element in that particular row, that particular column. So boron group, carbon group, nitrogen group, oxygen group, and so forth. So that should take you far. Remember the lanthanides and the actinides, the F block is down here. Lanthanides and actinides can be fit into this slot right here. So right between here and here, you can fit the lanthanide and actinide series. So that is that. So that is number 4. Number 5, be able to write the electron configuration of an element based on its position in the periodic table. So remember the system that I showed you for writing electron configuration, where you move across. We don't have to do that anymore. So what we can do is actually use the periodic table. So let's go ahead and look at an element. Let's look at magnesium, for example. Magnesium has 12 protons, so it'll have 12 electrons. So we want to be able to write the electron configuration for magnesium. So I'll do that just by going across the periodic table just like this. Right across here, this is the n equal 1 level, n equal 1. So that's 1s2 across here. 2s2, I'll come right across here because now I'm on the second main energy level. 2s2. Now I come to the P block, so that's 2p6. And then I come to 3s1, 3s2. So I'll write that on the other side. We'll come this way, and let me just go ahead and write that as the electron configuration for magnesium would be 1s2, 2s2. I'm in the P block now. 2p6. I'm in the third main energy level now. 3s2. So the electron configuration again for magnesium would be as follows: 1s2, 2s2, 2p6, 3s2. And you can write the electron configuration for any element using that, notation. So that concludes 1 through 5, and we'll pick up the rest of them in the next video. Thank you.